complex numbers example 16. This is quite a difficult example. You might want to watch it through first before trying to write anything down. There's two ways to do it. So this is going to be version 1 and I'll record a version 2 as well, and you can see which method you prefer. So I'll start by doing what we call equating real and imaginary parts, and I'll show you what I mean. So on the left hand side we have 3 minus 2i, and then we have z minus 1 plus 4i equals 7 plus 4i. Now, z is the thing we're trying to find, and z is a complex number, so we know that it's made up of a real and imaginary part. So I'm going to express it as x plus iy, that's the z, real part, imaginary part, and then we've still got the minus 1 plus 4i equals 7 plus 4i. So we've got lots of real numbers and lots of imaginary numbers on both sides. So what I'm going to do is expand it all out and start collecting some things together. So we need to be really careful when we expand this out. 3x plus 3iy minus 3 plus 12i. That's multiplying everything by 3. I'll now multiply everything by the minus 2i. So it's minus 2i times x. Now let's see if we can do this next term all in one go. We've got 2y, and then we're going to have an I squared. Now I squared is minus 1, but we also have a minus in front of it, so that will become plus. So just check you're okay with that term. The next one will be minus 2i, and then the last one, again let's try and do it in our head if we can. 2 4s are 8, it's 8i squared. Got a minus in front of this one, and I squared is minus 1, so that will become a plus 8. And all of that is equal to 7 plus 4i. So let's see what we've got. We've got some bits that have got x's and y's. I'll just underline those. And then we've got some bits that are just real numbers and imaginary numbers. So let's see what we've got on the left hand side. I'll put them together. So we've got 3x is real, and 2y is also real. I've got 3iy, that's imaginary, and I've got minus 2ix, that's imaginary as well. Now with the other bits, I'm going to take them over to the right hand side. So with the other real parts, I've got minus 3 plus 8 is 5. So when I take it over to the other side, we'll be subtracting 5, so that 7 will become a 2. And then we have 12i minus 2i, which is, oh, that should be plus 2i, sorry, yeah, that should be a plus 2i there, I've made a mistake. So I'll just change that to a plus. So 2i times minus 2i times minus 1 is plus 2i. So that's plus 2i there and plus 12i, so that's 14i. And when we take it over and take it off, that will become minus 10i. So just perhaps pause the video at that point and check you're clear on where we've got to at that stage. So the next step is to have a look at what we've got on each side. So I'll use some different colours. This part here is real. There's no i's in it. And that is real. There's no i's in that. So 3x plus 2y equals 2. That's comparing the real parts on both sides. Similarly, we have some imaginary parts on each side. So if you take away the i's and just look at the coefficients, I've got minus 2x, I'll write it so they line up, I've got plus 3y, and I've got minus 10. So you're just looking at the coefficients in front of or next to the i's. So we've made some simultaneous equations here. You can go through solving the simultaneous equations yourself. I'm sure you can work those out, 2 linear simultaneous equations, and when you solve them you get x equals 2 and y equals minus 2. Okay, so that's one way of solving them, and so the answer for z is that this number must be 2, which is the x, plus, minus 2i, because the y is negative, so it's 2 minus 2i. So that's one way of doing it, and then there is an alternative way of doing it as well. Instead of put in x plus iy, what I could do is just go back to the first line and just multiply it out as it stands. So, doing it that way and just leaving the z as z, you get 3z minus 3 plus 12i. And then doing the second term, you get minus 2iz plus 2i. That's the mistake I made on the last one. And then you'll get minus 8i squared, and that will become plus 8. And that's equal to 7 plus 4i. Now, if I collect together the bits that have a z in them, we have a 3z at the beginning and a minus 2iz. I'll leave those on the left, and then I'm going to take everything else over to the right. So I've got minus 3 and plus 8, that's 5. So when I take it over, that'll give me 2. And then we have 12i and 2i is 14i. Take that over, it's minus 10i. So you can see we're at the equivalent of this stage. Now what I'm going to do now is take that z out as a factor on the left hand side. So a complex number multiplied by 3 minus 2i gives us 2 minus 10i. And so what we can do is we can actually divide by the 3 minus 2i, and that'll tell us what z is. Now you can do these divisions yourself. I won't go through the steps of it here, but when you go through the process of multiplying by 3 plus 2i over 3 plus 2i, you can pause the video, check this for yourself. It works out to be 26 minus 26i over 13, and that works out to be 2 minus 2i, which is the same as we got earlier on. So you can choose which of those methods you prefer. I personally do the second one. It does involve doing a bit of division. You may prefer to do it the first way. It's entirely up to you.